This is a lecture from Open Tuition. For the free lecture notes that go with this podcast, please visit opentuition.com.
Now we're going to look at question 4 from December 2012. Question World Engines. If you haven't got this question available, then you must go now and download it. Don't try listening or following this lecture without having downloaded the appropriate question from the ACCA website. Otherwise you will not be able to follow the lecture properly and it will be wasted. So if you don't have it available, then pause the lecture now and go and download it. When you've done that, read through question 4. Read the requirements first and then read through the information in it. There's about a page worth of information there, and when you've done that, when you've studied a little bit, then start the video again and we'll start solving the 3 parts of it. So part A says develop a decision tree from the information given and discusses implications and shortcomings. So we have to remember this, okay? If you just draw the decision tree, I don't think you're going to get much more than 4 marks maximum. Part B, the divisional director suggests that the procurement decision should have been taken on the evidence of the decision tree. Discuss what other factors not considered by the decision tree analysis should have been taken into consideration. I think the difficulty in this one, as you often find, is how do you split them? Because if you're talking about shortcomings here, some of the shortcomings that we've got there is really stuff that should have been taken into account maybe in the analysis. So we just have to be careful not maybe to put too much into part A that could usefully be put in part B. And then we have a kind of slightly unpleasant part of the question. We've had this dreadful air accident. How could we try to reduce the risk for the supplier business failure and employee travel? Okay. Anyway, we'll start looking at our decision tree. So up here we are going to acquire some software. We can go to Amethyst A or Topaz B, and we're given here the returns depending on whether demand is high or demand is low in each of those. And then, as you would expect in decision trees, you're given some probabilities. So demand can be high for 6 years, or can be low for 6 years, or can be high for 3 and then low for 3. And we have the probabilities, of course, should all be adding up to 1. Okay, all of the outcomes should be there. So we start really with a decision. Are we going to go for Amethyst or are we going to go for Topaz? So we have our initial decision here, and we have the Amazon or we have the Topaz option. And then if we follow what's happening in the Amethyst one here, we can have high demand of 3 million or low demand of 0.5 million, or high then low. So I think we're going to have 3 options coming out: high, low, mixture. Okay, so it'll be 6 times 6 times, and it'll be 3 times plus 3 times, whatever that is. So the high demand or the high return was going to give us 3 and then 0.5 for the low. So 3 and 0.5 and then 3 and 0.5. So we're looking in there at 18, we're looking in here at 3, 3 threes are 9, we're looking in there at 10.5. And the probabilities within this, 0.4, 0.4, 0.2. Okay. The bottom one's very similar, a very easy decision tree, this really. We're going to have 6, 6, and 3, and 3. Okay. So the high demand we're having high return rather, 4 million and then 0.1. 4 million and 0.1. So times 4 times 0.1, 4 plus 0.1 equals 24 equals 0.6. So 3 4 is 12, it's going to be 12.3. Again with probabilities 0.4, 0.4, 0.2. Okay. So I call this X, Y, Z just to label them. Okay. So the expected value at point Y is going to be the sum of these here times the probabilities. So it's going to be 0.4 times 18 plus it's going to be 0.4 10 times 0.5 and then a big one, 0.4 times this one there times 3, then plus 0.2 times 10.5. So 18 times 0.4 will be 7.2, and be 1.2, that'll be 8.4, and we have that 8.4 and 10.4 be about, I think, 10.5. Are there costs in here? Oh, there, yes. Costs in here of 7 and 8. So what we'd have, the way I would do it is minus 7 in here and like minus 8 there. So at 10.5 there. So expected value at Z is going to be 24 times 0.4 plus 0.4 times 0.6 plus 0.2 times 12.3. And that will come, I think, to 12.3. So, at x, the expected value at x is either $10.5 less the cost of 7 or 12.3 minus 8, 4.3. And therefore, based on this here, we should go for the second one. We should be going down here, making this decision here, and going for topaz. So that's the initial decision tree, and we're asked in this one here the implications and shortcomings. Okay, it's implications and shortcomings. I think the implication is that based on this analysis, we would be advising people to go for the topaz solution, that it has an expected net value of 4.3, which is slightly better than the 3.5. What are the shortcomings in the method? Well, one of the common shortcomings in these methods is that the expected value is not actually really expected very often. We will either get, here it is in fact, but we'll either get 18 or 3 or 10.5, and the other one we're either going to get 24 or 0.6 or 12.3. It has in fact come out with some expected values here. Those are the expected values, But very often in a decision tree or an expected value type of solution, the expected value for a once-off project is actually unexpected. It's not actually one of the outcomes which is in any way being predicted. So you're making a decision based on a slightly phantom number. Secondly, I would say the shortcoming is how on earth we get these probabilities. 0.4, 0.4, 0.2. With only high demand, low demand, why is it going to be half high, half low? Why couldn't it be 4 years high, 2 years low, 2 years high, 4 years low, and so on there? How do we get the probabilities? How has anyone actually forecast what those are, indeed what the returns are going to be? And that's always a difficulty. And the final point I would say is risk. Risk is not satisfactorily taken into account in expected values or in decision trees, which is just a complicated sort of expected value. So if you take A here, this one here, the amethyst option here, which we're not going to take, but the worst that could happen is you spend 7 and the return is only 3, so there'll be a -4 there. That's your worst. That's your downside risk. Could be that. If we go for topaz, then of course the worst that could potentially happen is -8 plus 0.6 worst. -8 in cost actually only gives us 4 years at 6 years at 0.1 in there. It's going to be -7.4. And you have to think, could the organisation actually survive a loss of 7.4? It might be able to survive a loss, we don't know, of -4, but there's a heck of a difference in the two worst case scenarios. But that's not taken into account when you just looked at the kind of expected values and went for the highest. It conceals a lot of information about risk. And that's what I would say. I would probably confine my answer to part A just to that. So now let's look at part B, and hopefully we've kept enough points back to have some other factors not considered in the decision tree analysis. And this is probably going to be project or scenario specific here. So let's go up and see what other factors we might want to have brought in. Didn't want to come back to that, which we could bring. It's only 6 marks this, so if we think 1.5 marks per item, probably you're looking for about 4. Okay. These improvements include the introduction of specialist hardware and software. 2 companies have been shortlisted. Amethyst, a well-established company, and Topaz, a relatively new company, formed 3 years ago. Okay, that's something we haven't really taken into account. The richness of experience, the stability of the companies. We don't want to be buying one of these pieces of software and then find the company goes into liquidation because we're left high and dry without really any backup, particularly. New companies, I think there's more risk in there. And this risk hasn't been taken into account even with the 0.4, 0.4, 0.2. That was to do with returns. So we could mention, I think, the different ages of the 2 companies. It uses a conventional programming language, whereas but the solutions widely used was relatively inflexible and out-of-date user interface. So when you are buying software packages, you should be looking at functionality. What does it do? You should be looking at reliability, response times, user friendliness, and what the user interface is like, and flexibility. These are all considerations that we need. And here it's inflexible and it's got an old user interface, which is maybe awkward and difficult for people to use. Our new company, maybe not as stable as we have already said here, but It says here it's a modular software design that allows it to be easily maintained and updated. It's in a new programming language, so it's probably got more future in it than perhaps the other programming language, and an attractive and contemporary user interface. So it seems to be winning a lot there. It is much smaller, of course, turnover 24 versus 960, but provided we can assess the kind of liquidity and the profitability and so on of this small company, it might be really the one to go for. And it has said here, yes, it is profitable, liquid and lightly geared, and that's something to take into account. Think of it as just the other way around. If it hadn't been profitable, or there's bad liquidity, you'd say, no, I don't want to be going close to that, no matter maybe what the financial benefits are going to be showing. Further on down here, they have the division director reports that the returns are based on tangible benefits resulting from the two options. So presumably there are going to be some intangible benefits. Intangible benefits can be things like employee morale. Remember this newer company, Topaz, with its attractive, up-to-date interface. Maybe it's an easier interface to actually navigate, and you get your work done better and more easily. And then just working in a company is more pleasant. And employee morale can be important. If morale is poor, then you will be losing these valuable skilled programmers, and you've got a big burden to try to recruit them. So that is important. The returns reflect the characteristics of the two products. The Topaz produces better returns of demand. We know this, less effective in low. We knew it was a very small return if low. But they differ in their functional power and scope. Yeah. So I did say you have to take into account the functionality of the software as well. So I think we've got probably other things not taken into account there: the stability of the company, the programming language, and the modular construction. There is different functionality, which we've just talked about in here, different interface as well. And that's I think is, and we could also say maybe things like the size of the software house as well. We know this is a much smaller one, and even if it was financially stable, could Topaz deal with us? If we're a very large company, it's a small software house, and we end up being kind of 80% of its revenue, it might actually find it difficult to deal with us and its existing clients. And those are what I would be taking into account. Part C. We executives are concerned about the risk of Topaz, a relatively new company going out of business. They've also expressed concern about the loss of the evaluation team in the fatal accident, and they believe that this should lead to a review of the risks associated with employee travel. Discuss how each of the risks above, supplier business failure and employee travel, might be avoided or mitigated. Okay, let's start with the employee travel and this unfortunate accident which they have. And again, you should try to feed off the question and use any of the details. Always regard details given as potential ammunition that you can use in answering the question. So here's the bit dealing with the crash. On a recent evaluation to Amethyst, WE's complete evaluation team of 5 people. So maybe one thing we should do is not have all our eggs in one basket, or all our evaluation team in one aeroplane here. Many large companies have a policy that their top staff will not travel together in case of some accident. So you can easily put some sort of a rule like that in there. It was this was the aircraft was crashed on its approach to its landing. It was small, 12-seater commuter aircraft. Well, 12-seater small aircraft these small aircraft tend to have a much less impressive safety record than large commercial jets, for example. Large commercial jets are almost certainly going to be much more regulated. We don't know if this was like their own aeroplane, or whether it was like a hired specially for us, or whether it was a regular commuter aircraft run commercially. But small planes tend not to be as robust, as safe as large planes. So maybe we say, don't go in small planes. And even when you get up and tell people you must go in commercial aircraft, some companies will say you will not ever fly with that airline company, because there are well published statistics of basically the crash rates of different airlines. And they will say, don't go with that airline, it has an awful history, you're simply not allowed to be doing that. And it was flying on a short 100-kilometre flight from the international airport. Well, why were they flying 100 kilometres? 100 kilometres is something you would probably be able to drive in an hour or something of that sort. It seems extravagantly expensive. And maybe it was actually, a bit unnecessary there. So maybe what we should say is less air travel. Although we have to be careful on that, because actually, generally speaking, air travel safety statistics are very good, probably better than cars and so on. But we could, I think if it tells you it's 100 kilometres flight, you begin to wonder, well, why were they on an aeroplane at all? Really, maybe we should set a minimum distance or a minimum time it would take before you're allowed to fly. And then it went from international airport to a small rural airport close to Amethyst's base. It doesn't say which one it crashed at. It says on a visit to Amethyst. The team, maybe it was going there when the crash. Yeah, okay. I think we could read into that it was hitting problems when it was going towards this small rural airport. And small rural airports probably don't have the sophistication of radar or the landing systems that allow you to deal with fog and so on there. Maybe the surface of the runway isn't is good either. So you could say, no, you have to fly to regular commercial airports where they have all the facilities and proper firefighting and so on. And then it does say it later emerged that small commuter airlines and aircraft were subject to less stringent safety procedures than large ones. So we should read the whole thing first, really, and say that stay away from little ones. It might also be a possibility, do we need all 5 of them to go? Do we need to actually physically visit people as much? Could we not do maybe teleconferencing as a way of reducing that as well? So that's something we haven't just made it up. We've gone to what it says in the question and tried to pick up the little bits of information given there, because you won't really have thought, I think, very much at all. It's certainly not explicitly covered in the syllabus. How to protect members of your staff from accidents during employee travel. Supplier business failure is the other one here. How could it be avoided or mitigated? We had identified, of course, Topaz as being a new company. So first thing you can do is make sure you look at their financial statements. Maybe you can get reference from credit references about them and so on, some sort of investigation and so on. Generally speaking, if you buy a piece of software, you do not own the software, you license it, but there are legal arrangements called escrow, and what that means is that here Topaz would put a copy of all the software with a lawyer, with instructions that this software could be released then to customers in the event of the software company going into liquidation. So you get a hold of the original software really then as a customer, and then you should be able to amend it and change it and update it as you need to. It says it's a new programming language. I would think about maybe we should get some employees who can operate this new programming language. They might be able to eventually kind of get involved a little bit and get more knowledge of what's going on in this software. We might even be thinking at some point of developing our own equivalent system rather than having to rely on perhaps Topaz at all there. But I think those are probably the main ways in which we could really kind of mitigate that. There is the escrow arrangement, in-house expertise, both for updating it and if the escrow has to come into effect, and so on. Another one is we could also maybe say to Topaz, look, if you run into some sort of financial trouble and you need help, then come to us first. We rely on your software, and if you got into these sorts of difficulties, maybe we could extend you a loan, or maybe we would take you over, or maybe we would buy this piece of software and bring some of your programmers across, and so on. But don't hide your problems. Don't stay silent until the end. Take us into your confidence, and we'll see if it can be rescued, because it's really important to us. It might also be worthwhile having another potential supplier up our sleeves. Quite difficulty in terms of specialist software.